Now that you know how to read the periodic table and get all the information that you need off of it, it's time to start making some models of atoms. We did this already in the Explore station of your lab, but we're going to review together. I'd like you to take a few moments and pause this video, and on the next blank page in your notebook, I'd like you to copy this chart that's on the screen. Make sure that you have the atomic number, element name, element symbol, atomic mass, number of protons, number of neutrons, and number of electrons. Going one way and going the other way, you can fill in the items that I gave you in the correct rows. We'll go through and fill in the rest of it in just a minute. Pause the video, and when you're ready again, you can push start. All right, now that you've got that copied, let's take a look at this. We're going to do the first two rows together, and then I'll turn you loose to do the rest of it on your own. The first row tells us that we're looking for carbon. If you remember from the other day when we go to the periodic table, this is what we look at. Okay, we talked about silicon the other day. The atomic number is at the top. That's the number of protons or the number of electrons because they're usually equal. The element symbol is that abbreviation, the letters that stand for it. The atomic mass is the protons plus the neutrons. And then the element name is at the bottom. That tells you what element it is. So in this case, we're going to go to the periodic table. We're going to look for carbon. Here's what your carbon square on your periodic table should look like. This tells me that the atomic number is 6. So I'm going to go back, and in my table, I'm going to fill in that the atomic number is 6. Then I have to find the element symbol. It has a big C. This is my element symbol. C stands for carbon. Next, I need to find the atomic mass. For the purposes of this activity, and any time really that you're drawing models of atoms, we're going to round the mass to the nearest whole number. So the rounding rules tell me that whatever's after the decimal, if it's 5 or higher, we round up. If it's 4 or less, we round down. Since this is 0, 12.011 is just going to round to 12. So we're going to go back to our chart, and we're going to put 12 where it says atomic mass. Okay, if you remember, my atomic number tells me how many protons there are, and since that also is the number of electrons, we know now that we have 6 protons and 6 electrons. Then the only thing we have left to do is find the number of neutrons. To do that, we're going to do a little math problem. You need to write out this math problem. If you remember, the mass, or in this case 12, is equal to the number of protons plus the number of neutrons. So we're going to write out 12 equals 6 plus n for neutrons. And if I subtract 6 from both sides, I get that n equals 6. There are 6 neutrons in this carbon atom. Okay, so now that I've got all this information about carbon, it's time to draw it. So we're going to put a C in the middle to stand for carbon, and then we're going to start putting our electron shells. If you remember, in 6th grade, we're dealing with 3 electron shells. Okay, if you remember, C needs 6 electrons. Okay, keep in mind our first shell can hold a total of 2 electrons. Our second shell can hold a total of 8 electrons. And our third shell, if we need it, can also hold 8 electrons. That was all a review from your Explorer station. Now we got to figure out what carbon needs. Remember, you got to fill the inside shell first. So carbon only needs 6 total. So that means in my first shell, I'll fill it up and I'll give it 2 electrons. Then if I do 6 minus 2, I'm left with 4 electrons. Since 4 is less than 8, all 4 of those electrons can live in my second shell. So I have 2 plus 4 makes 6, and then I just got to put them on my diagram. So I'll put 2 on the first shell. Electrons are kind of like magnets. They don't like to be close to each other, so I'm going to put them far apart. Then when I go to my second shell, I'm going to go in a circle. 1, 2, 3, 4. And since I used all my electrons, I have 1, 2, 3, 4, 5, 6. My first shell is full and happy. My second shell is only half full, but that's okay because I used them all. I don't actually need the third shell this time. So I'm going to erase it. And then I have a complete model of a carbon atom. Make sure you've got that copied into your notebook as well on the next blank page. And then we're going to go ahead and we're going to do the next example in the chart. Your next example in the chart was number 2, atomic number 2. If you go to your periodic table and you look for atomic number 2, you're going to find helium, He. So we can fill in that part of our chart. This is helium. Helium's symbol is He, its abbreviation. Notice when you're writing element symbols, the first letter is always capital, and if there is a second letter, it's lowercase. If I go back to helium and look at its mass, the mass is 4.002, which is just going to round down to 4. You can fill in the mass of 4. To find the number of protons, remember we just look at the atomic number, which was 2. So that tells me I have 2 protons. Since the number of protons equals the number of electrons, that means I also have 2 electrons. The last thing we need to do is find the number of neutrons. That's that math equation if you remember. So I do my mass equals, so 4 equals 2 plus neutrons, 2 plus n, and 2 plus 2 is 4, so that means that I have 2 neutrons. Now that we've got all that information, we can work to draw a model of helium. Find the next blank page, or if there's room below carbon, you could put it there too. And we're going to start drawing a model of helium. So, just like before, we're going to put He in the middle. We put our symbol in the middle. And I'm going to start with my first shell. Helium, so He needs 2 electrons total. You always want to start by writing out how many total you need. Then you want to remember what your shells can hold. So the first shell could hold 2 electrons. The second shell could hold 8 electrons. And the third shell also hold 8 electrons. This time, though, helium only has 2. So how many shells are we actually going to need? Well, the first shell can hold a total of 2, and that's all I have. So my first shell is going to have 2 electrons, and then I'm actually done with this model. So I'm going to put those electrons far apart from each other because they don't like to be close. I'm going to count them to make sure I got them all. 1, 2. Helium has 2 electrons, and that's how many it needs. So I'm done with this model. Now, if you take a look at your chart, you're going to want to make sure that you have that helium model all drawn out in your notebook. If you look back at your chart, there are 1, 2, 3, 4, 5, 6, 7. 7 more to do. Now, instead of just drawing them all out, because that's kind of boring, you can grab a baggie of Cheerios from the front counter, and you can create these atoms using Cheerios. Just get a piece of paper or a whiteboard to draw your shells in. Make sure that you're putting the element symbol in the center, and then draw your shells around it, and you can use your Cheerios as electrons. Now, just in case Mrs. Larson or I cannot come check you right away, so that you don't have to sit there, you can use your computer and you can take pictures of them and put them in a Google Doc and call it atom models. Or you can make multiple models on your desk at the same time and then call us over. Whatever you choose to do, somehow Mrs. Larson and I need to approve the rest of these models. Beryllium, the one for atomic number 12, phosphorus, the one for atomic number 9, aluminum, the one for atomic number 8, and sodium. Every single one of those, all 7 of them, must get approved. They must be correct before you can move on to the next thing. So take your time, check your work, and try to have some fun making these models. Good luck!